Okay, so let's get started. So tonight we're going to take a look at deepening fraction understanding using Cuisenaire rods with Kate Gracioli. Kate has been an elementary teacher. She's taught middle school math. She is currently a Title I math division coach. She works with teachers and with students. And she recently earned her PhD in education, specializing in math education and teacher education. So we are really excited tonight to learn about how we can deepen students' understanding and possibly our own using Cuisenaire rods. So with that, I am going to stop sharing, Kate, and let you have some fun.
All right. Thanks, Mark. As he said, I am Dr. Kate Racioli. I am a elementary division math specialist in Northern Virginia. I saw some of our friends in the chat, those from Woodbridge. It's nice that you hopped on. I'm also an adjunct professor at George Mason, and one thing I'm super passionate about is equity-centered technology integration, and that's one thing I love about how Brainingcamp has these virtual manipulatives and some of the fun things that we can do. The work that we're going to do today is we're going to explore Cuisenaire rods. And yes, these are on Brainingcamp, but some of the stuff that we do here, you can also do with physical Cuisenaire rods. So if you're thinking about how you might transfer this learning into your classroom, you can consider how you might use physical Cuisenaire rods or how you might use the virtual manipulatives. So today we are going to explore some Cuisenaire rods. What are they? What options do we have? We're going to represent fractions with Cuisenaire rods. We're going to explore equivalent fractions, and we're going to compare fractions with Cuisenaire rods. There is a lot more we can do with fractions, but in our limited amount of time, I'm hoping we can get to these things and kind of build some of our rational number sense using our Cuisenaire rods. So we're going to jump right in and let you play. So when you go onto the code, this is the code that you're going to type in where Mark has said to type it in within Brainingcamp, and it will take you to a live Cuisenaire or live Brainingcamp session that will allow you to play around with the Cuisenaire rods. There's a lot of options of things to play with. So you can play with the orientation. You can add some grids, see what happens. Click around. My favorite thing to make sure that you want to click on is workspace. This is one that when I'm in different Brainingcamp tools, I always forget about the workspace and like how different things exist within that tab. So use the code, start playing around. What can you do with this tool? Here's the code again up on the screen. I see we have a whole bunch of you already in playing around. I'll give everyone just a couple minutes to join and play. If you need, you're going to log in to Brainingcamp and you're going to enter the code at the top. So if you should be on this screen, make it a little bit bigger. There is a share code box. You're going to type in here. So make sure that you are signed in and you'll see the share code button. To get logged in, you will need to make an account using the code RODS, which Jeff is putting in the chat. There could be some issues with your account. I know for this session, I'm using a special account that's not my division account because that requires Clever access. So if you're having issues, I would create an account with your personal email, because sometimes with your work accounts and single sign-ons, it gets not so easy with this type of environment. But no, with your students, you would all be logging in at the same way, and you can do this without that issue. But for this webinar, it might be easier to create your own accounts. All right, it looks like we have about 78 of you in. Give everyone else a couple more minutes, because I see there's about 193 in the session and about 85 of you in the live session. We will talk about the magenta. All right, I know that some of you will be continuing to join our live session, but I want to show you some things that I want to make sure that you've noticed. So as you pull them out, just like other Brainingcamp tools, it will stack in row. You might have started to notice the relationship between the different rods. And then as someone said in the chat, we have the extendable magenta, which adds the extra piece that the physical Cuisenaire rods don't have. The physical Cuisenaire rods stop at just these pieces, but virtual means that we can be amplified a little bit better, and I can have a completely extendable magenta rod. You could add in a grid background. You could add in some unit lines to the rods themselves, depending on what you're using them for. As Mark said in the beginning, Cuisenaire rods are one of the most versatile tools. So we don't always use them for fractions. You might use them for whole numbers as well. So there's different workspaces. There's the basic. You can add whole numbers to them. You can add decimal numbers to them. You can add letters, and you can add fractions. For this work, we're going to be sticking with letters, because with fractions, it limits it to this is 1 whole and this is 1/10. But Cuisenaire rods don't have to be like that. We don't have to do orange. We don't have to say orange is 1 whole. So we're going to turn on letters. This is brown, and because we have two blue, like two B's, so N is brown, E is blue, K is black. So that's why the letters don't always make sense at first. All right, so now that you've played around, I see some of you making some beautiful images. And just like with their students, we want to make sure that they have time to play with the Cuisenaire rods. Before, whether it's virtual or physical, we want to play with them before we allow them to do some math with it. I added the letters by going to Workspace and then clicking on Letters. So I'm going to be sending a code to you. And you now all have a task on your screen. What I'm putting in the chat is the live code. So those of you who are in the live session, you have a task on your screen. If this white piece equals 1/2, what would be 1 whole? And then we are changing the value of the white piece to 1/3, 1/4, 1/5, all the way up to 1/10. So in your on your pages, play around and see what you can figure out. Give you some time to play and explore with a specific math task in mind. Start to think about how you know and how are you figuring it out. I'm changed it to letter so that way we don't have any issues with different screens. And if we're talking about green, we know which one is green and we know which one is black and brown because different screen monitors have different uh, tones and not everyone can see every single color. So I always like for accessibility purposes to keep the letters on so that way everyone's talking about the same thing. All right, it looks like some of you might be seeing some patterns. You are in the live session. You should see this task. All right, I see some of you are even justifying your work by using the whites pieces. And if you take a glance at your Zoom screens, you'll see what I can see as the instructor or the facilitator. I can see everyone's work along the side. So if I am the teacher in a classroom, I can be monitoring what students are doing, and I can at a glance see where everyone is at. And it looks like most of you have thought about it and have come up with some answers. So this is, for this one, this might be the only answer, but here's how you might have thought about it. And I push it out to everyone because I know going back and forth between Zoom and Brainingcamp can be tricky. So I'm sorry if I messed you up in the middle of what you're working on, but here is how you might have been able to figure out. If we know that a half is made up of two equal parts, I know that two whites would be next to each other, and I have to figure out what piece would be equal to two whites. If you need to group the rods like that, you can just kind of click and drag over them and then move them out of the way. I'm not sure if that's what you're asking. All right, you ready for your next task? We're going to try another set of tasks. There are 3 on this page. Now, they can be a little tricky to figure out, like because it's too far away. There is a zoom button down here with the plus magnifying glass. It might be helpful to zoom in a little bit and like scroll over so that you can see the 3 different tasks that are on this page. So I'll give you some time to think about if orange is the whole, what's yellow? What's red? What's white? All of these codes are the same as a normal share code. I'm just doing it all within live so that we don't have to keep on going out and coming back in different live sessions. So that way you guys can be in one place. If you want to type in Brainingcamp, there are these other buttons kind of up here at the top. So the objects will be always the manipulative that you're clicked on. And then shapes and tools are the same for every manipulative. So in shapes, you have a text box that you can type. So you can type that way. You can also use the pen tool and draw with that. And I see some of you are almost done already. Awesome. All right, so for those of you who are still playing, I'll let you keep playing and I will model up on this screen. So if I'm trying to figure out what yellow is, I might that page. To scroll there. There we go. I might need to pull out orange and then figure out how many yellows does it take to make an orange. So if it takes two to make an orange, that means yellow must be a half. Then I can do the same with red. Bonus is that you can just click on that multiple times and it fills it in. It says it takes 5 reds to make a whole. So that means each one must be a fifth. And then how many whites? Oh, that was too many. It takes 10 whites to make a whole, so that means it's a tenth. We can also consider questions like this one, if this is a third. So now we don't know what a whole is. We have to figure out what a whole is. So if this is a third, I know that we need 3 of them to make a whole. So that would be 1, 2, 3. Then I have to figure out what equals this. Well, that was too long, so I could do that. And a lot of people are saying that using the grid lines is helpful to figure this out. So you can decide whether you think grid lines is useful or not useful. And then we have orange and a red. Now, if you are using the physical manipulatives, this is how you can get 12ths. Because a white, if you are playing with it, you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you need 12ths, you just stick an orange and a red together, and that's totally a legal move in Cuisenaire rods. We don't have to end at orange being the largest whole that we can divide up. You can put 2 pieces together. I am adding the rod repeatedly by just constantly clicking on the white. So if I drag one right here, I can keep clicking on this and it will add to the row. And if I want to add some reds, it'll add there. But because I am in a virtual manipulative, I might not need to do an orange and a red because I have the magenta. And I can make this whatever length I want. I can make it this 12 whites long length. The coolest thing that I noticed when I was playing with this that I didn't realize at first is when it's the length of the orange, it changes it to an O. So you know that you could use the O. You could use the orange. If you change it to the length of a blue, it changes it to an E because it is the length of the blue. So I thought that was cool that when it's smaller than the orange, it changes it to the letter that it represents. But instead of having to put the orange and the red together to make 12ths, you can use the magenta piece, which is really cool. All right, so we've represented fractions. I want you to reflect on the work that you have done with playing. We represented 2 different ways. I want you to reflect. What are some of the affordances and drawbacks of using Cuisenaire rods for representing fractions? What are some things? I already saw that you guys noticed that there are, the grid lines are really useful. What other things might you have noticed that you think is cool? And maybe some things that fraction bars are better. You haven't convinced me that Cuisenaire rods are better than fraction bars. You can hold doesn't always have to be the same size, which is great, especially for our littles to understand that. We can show fractions greater than 1. the value isn't on there. I know in our state, our students that have math IEP goals cannot use fraction parts with fraction numbers on them, but they can use blank ones. So Cuisenaire rods is a tool that they can use on our state assessments, which is kind of cool. You can add it like a number line. We can add the letters. We are reflecting in the chat box. Right, you can totally connect it to everything. Like this session is specifically on fractions, but it works. You can use Cuisenaire rods for multiplication and division and adding and subtracting. It's, yeah, the purple rod, everything is limitless. It's really cool. So I did see one limitation in the chat that I don't know if everyone saw, but I think it'll come out as we do some of these things. You do have to be strategic in what you're asking students to do because not every combination is possible. And I think that'll come out as we start exploring comparing. You cannot necessarily compare every single fraction with itself because the whole can change. So we're going to get into equivalent fractions now. So I'm going to send you a new task. And play. If the brown is a whole, what's a half? Are there any other ways you can represent a half? Some of you are already jumping right in. You're using the brown at the top. You might see what rods fit. I'm noticing a lot of you are using the brown that's there and seeing kind of what fits underneath of it. Kind of building. And we know that fractions have to have equal parts. Have lots of nice little rectangles. I'll give everyone a couple more minutes. Some of you are being very creative with your ways to make a half, which kind of gets into the decomposing. I didn't even think about how this also gets into ways we can decompose a half as well, which is kind of cool. I'm seeing that some of you are also thinking about how we can make a half with a different whole. Someone has pulled out the dark green and saw that two light greens go underneath. So if this is the whole, this is the half. You might need to refresh because I see as I'm scrolling through looks like some people have like lost their internet. So you might need to go back and come back in. I can share your screens with the audience. So like I could pull this one up and open it for everybody to see via the Zoom or in my classroom. I could pull up a student's work to share and discuss. I can also push it to everyone's screen like I've been pushing our tasks out to you. So this is not the only way because you guys came up with some very creative ways to represent a half and really understand what a half is. But here is one way you might have thought about it. I saw lots of stacking in this kind of vein happening. So Cuisenaire rods can work for equivalent fractions. When I was deciding which one to choose, which goes to some of the limitations some of you noticed in the previous reflection, I chose brown as my whole because I knew I could come up with at least 3 equivalent fractions for 1/2. I could do a half, I could do 2/4, and I can do 4/8. However, if I did it for blue, can anyone find a halves for blue? If you find the color for a half in blue, put in the chat. See if you can figure it out, or is it impossible? Darren thinks there isn't one. Can anyone prove him correct? See some of you bringing it out on your screens. Someone says yellow. Can I fit 2 yellows? Yellow's a white piece too long. And if I go one smaller, I'm a white piece too short. So not every color has a full piece that's half. Yes, we could do purple and half of a white, right? We could be creative to figure out where a half is, which actually could be really cool for your students, right? Because you could, having that discussion, I know that when we're talking about comparing and ordering, finding half of 9 white pieces, they kind of need to know approximately where that might be. So when you're choosing pieces, you can't just choose any of them depending on what your math goal is. So if you want them to figure out what half of 9 is, you could, but that might not be your goal if this is your task. So I know that was something that that magenta doesn't quite work because it jumps to each one is off by a white. So I can't stop here halfway, but you can kind of see it's the purple plus half of white if you do that. All right, so we've done some equivalent fractions, and you could do the same thing with all the other equivalent fractions that you have played with that you might need to know depending on your grade level. So thinking about equivalent fractions, what are some reflections that you have? What are some of the affordances or drawbacks? Is this a tool you would use for equivalent fractions, or would you choose something else? You were saying absolutely they would use it. You like the visual. Definitely allows for the exploration piece, right? And then pulling out something that is an odd number of white pieces long would add to like a really amazing conversation. All right, so we're not finding that as an issue. Cool. All right, let's see how we feel about comparing fractions. So on this task that I'm going to share with you, there are 3 tasks. Which is greater? 3/7 or 5/7, 2/5 or 4/5, and 6/9 and 7/9. Kind of want you to put your 3rd grade hat on. I'm sure that you know without building it, but prove your answers using the Cuisenaire rods. What pieces are you going to need to use? Can you build each one to prove which one is greater? And how might this help to generalize what you already know as adults? So I'll give you some time to play with these. Yes, I believe that Mark will have a document that will have all of the share codes in it. If your screen didn't change, I would do just a refresh of your browser and it should change because I see some of you, it looks like it's stalled out or something. I see some of you are playing around with this. Some of you are very fast and quick with this tool. So this is different than if we're using fraction bars, because do most of our fraction bar kits have sevenths in them? Most of them do not. I don't think I've come across one that has sevenths or ninths. But with Cuisenaire rods, we can find sevenths or ninths. We just have to be flexible enough thinkers to consider that our whole is going to be different. So I can see like this person use black for their whole for sevens, use yellow for their whole, use blue for their whole. And you won't always have to use one piece for your whole too, right? Because when we did the 12s, we did the orange and the red. So if you want, it doesn't always have to be one piece. And I noticed that some of you were trying to prove like this person was proving that the black piece is worth 7 white pieces. And they can see the 3 and the 5. Now I'll show you how to do this in a second. All right, it looks like most of you who are in have an answer. So I will let you keep going, but let me pull up this screen. So I used black as my whole for the sevenths, orange as my whole for the fifths, and blue as my whole for the ninths. Other people use a different color for the whole for the fifths, but they use the white as each as 1/5. But red could work too. Red is worth a fifth if orange is a whole. And the way that I represented this is when you click on a color or on a piece, you can do fill on or fill off. Some of your students might have a tricky time understanding like this is still worth the same. So by turning them colors on or off, they can see that these pieces are still my equal parts of my whole, but I'm only considering these first 2 pieces or these 4 pieces. So we can see that 3 of the same size piece is less than 5 of the same size piece. The same thing here. So what did you notice about these 3 sets of fractions that I presented to you? Yes, I really like that fill on and off. Yes, you saw my trick because you are adults. They all have the same denominators. And so since we know they all have the same denominator, what generalizations can we make about fractions with like denominators? Right, I see a lot of we only really need to look at the numerator because we know that our pieces are all the same size. So if I know I have 3 of the same size pieces or 5 of the same size piece, the 5 of them is going to be larger. And our students need to be able to play with these tools and explore and build in order to develop this generalization about which one is greater by looking at these common denominators. And by building it, it helps them build this generalization. If we just tell them, oh, because they have a common denominator, you can just compare the numerators, that can be tricky in their understanding because they haven't built it yet. So building can help with that generalization. All right, let's try another set of tasks. Let's see if you can figure out So, Jana, you need to use a different color to represent the whole because not all fractions fit for each one. So, for the last set, this set, I needed black to be my whole so that I could make sevens. Otherwise, if I only ever use this orange piece, there's a limitation to what I could make with it. So there's white would fill completely, red does, but I could not use this green piece because it does not equally divide up my orange into equal groups. So if I wanted to use green, I could use, is it blue as my whole, and then I can have thirds. And it helps students become flexible because the whole matters. The slides will be shared. I believe that Mark has already PDF. All right, see lots of playing happening. Oops, some people turned on the grid background, which is an option, which also matches if you turn this on and the grid lines on, that could potentially be helpful. I'll let you decide if you think that's helpful for you or not. All right, looks like some of you are still trying this one out. It can be tricky to find the correct pieces that fit. All right, I'll give everyone about another 30 seconds to play because I see people who are still actively working on solving these tasks. And I don't want to steal your fun because that's one of the fun parts of joining one of these webinars is doing math. So in this tool, all of the colors are always there. But even for the younger grades, you might let them play with them all, but they might just suggest, okay, we're only going to deal with these when we're dealing with fractions. But because you can also add and subtract with these with whole numbers, could be used to using all of the different colors. All right, I will, instead of interrupting, I will just show an answer. Not that one, this one. This is obviously not the only way to do it, but this is one way to do it. And I was trying to think of ways that you could do it without just using white as one of the options. So for the third one, I use magenta as my whole and greens to fourths and purple to do the thirds. And this is equivalent to 12 whites. If you could count that, but 3, 6, 9, 12 whites, which kind of gets at that whole idea of common denominator. But we don't really need to know. Yes, magenta to the rescue. Obviously, we don't need to do common denominator when we're comparing these sets of fractions, but it's getting us to that point where we might need to use common denominator when we're adding and subtracting these things. So that kind of emerges from this play and this work with these fractions. So you could use brown for the whole for the first set. You can use orange as the whole for the second set. And you can use magenta for the third set. But you could use magenta for all of them if you felt like it. There's multiple ways to kind of solve this, which is cool. So, what did you notice about these sets of fractions? You already knew what I was going to ask you. Yes, we have to use the same sign of whole when comparing fractions, which is super important. We can't just say, like, this is a fourth. I'm just going to say this is a fourth because I see four pieces. And I'm going to say that's an eighth because it has eight pieces. That's not how it needs to have be. We need to be comparing the same whole. But yes, all of them have the same numerator. So because they have the same numerator, what generalizations can you make about fractions with like numerators? What did playing with this, this one, help you understand about fractions and comparing common numerators? Right. Instead of looking at the number of pieces, we're looking at the size of the piece. So fifths pieces are bigger. And this is where that turning off the color, someone was talking about this last time, is really important to help the students see we need all of these pieces to make the whole, and that these fourths pieces are just larger chunks. And by building this and exploring this, helps that students with that misconception that eight must be bigger because I know when I did whole number understanding, eight is larger, but it takes more of those to build up to it. Thank you. You're right. 3/10 is not the correct answer. Good catch, Julia. All right. I know we're almost running out of time, but there's one more I want you to play with. Try this one. See if you can figure out what I'm trying to get you to get from this set. I love that some of you are jumping in right away, trying to explore. All right, some of you will see what I'm trying to get at. Let's see how Cuisenaire rods can help us build a generalization of how we can compare these fractions. Thank you for being so observant. Give everyone a couple more. Oh, I see someone's trying to play with the magenta. See how this is going. Awesome. That's so cool. Because why can't we just make the fourth, the purple, the fourth? Just make that a magenta, whatever color, whatever length I want it to be. That's so fun. Here's some more magenta work. Use magenta to do purples. Awesome. I'll give everyone a couple more minutes to play. I see most of you are on the first or second one. And what's kind of cool as you're trying to select these, I can see some of you are already like making the connection about what piece I need to take. And you're developing the relationships between these denominators as you're selecting pieces. So although this focus is on comparing, there's a lot of other understanding that is starting to emerge as you are selecting the pieces that you need to do the comparisons, which is kind of cool. So this is not the only way, but this is one way you could have determined which one is greater. And I already saw some people in the chat. They saw what I was trying to do. It was all one away from a whole. So, what generalizations can we make about comparing fractions that are one away from a whole? Right? We're looking again at that denominator, but we have to think differently than we did when we were thinking common numerator because we knew it's almost like that backwards thinking that fourths are bigger pieces, so I'm further away from a whole. And eighths are smaller pieces, so I'm closer to a whole. And tying this to a number line could be helpful. We have number lines in, obviously, this is a whole number. I might turn off all the labels and everything, but you could use a number line to help if that is useful to you in helping students turn this off. But if you're trying to make that connection to the number line with the 0 and the 1, adding the number line on there could be a helpful tool. All right, so I know we did a lot of different tasks. And I know we're all at different uses of using Brainingcamp. Some of you, this is your first time. Some of you have been using this a lot. If you kind of got lost and just kind of sat back and watched, I highly suggest you go back and watch the webinar again, or just play. The more that you play with the tools, the more comfortable you will be using them. But I just kind of want you to think about, we'll skip to the last slide. How do you think you might use this tool with your students? Is there a particular type of task that you want to try with them? Do you just want to get them on playing? What are you thinking about how you might use this tool in your classroom?